3. Okay, so 2.6 limits at infinity. Remember a while back, last week, I said there were two different things. Infinite limits and limits at infinity. Of course, infinity or negative infinity. This one we discussed last time, and we said limit of 1 over x as x approaches 0 from the right. And what did we get? Anyone? Anyone remembers the graph of this function? For this function, we don't have to think. We never need to think for this function because it should be in the back of our minds forever.
Is it positive infinity?
Thank you very much. But here we're talking about something else. Here we're talking about limit as x approaches infinity, or limit as x approaches negative infinity from a function. So limits at infinity is when, I touched that cable again, sorry. So I was worried that we got cut off again. So the limit of f of x as x approaches infinity, so limit at infinity, when x approaches infinity. This one is when the result, the answer is infinity, which obviously means that x equals 0 is a vertical asymptote. So basically this idea is for vertical asymptotes. And this idea, of course, is for horizontal or slant asymptote or asymptotes. So whenever I want to determine or find out whether a function has a vertical asymptote, I will definitely think and hope, or not hope, but will get plus or minus infinity here. So that means a vertical asymptote. And here I'm looking at slant asymptotes, infinity, negative infinity, or infinity, negative infinity, or horizontal asymptotes when it goes to maybe two different ones. So we do have functions that have different asymptotes. One specific one at infinity and a different one at negative infinity, and I will review some graphs with you right now. But if I were to ask you here for this function, what is the limit as x approaches infinity or negative infinity of 1 over x, what will you say?
Be 0?
Exactly, because y equals 0 is a horizontal asymptote. Exactly. So we have to deal with the limits at infinity for the next, I don't know, half an hour or more. Okay, so let's look at a few graphs that are carved in stone, and please remember these because we're going to use them all the time. So e to the x. Please remember the graph of e to the x. I'm going to try to use different colors so it looks better. Oops, it doesn't touch. It does not touch the x-axis. So this is e to the x, and this is y equals 0 is a horizontal asymptote at negative infinity only. Okay? Now, we can also look at natural log. This is natural log. Natural log does not have a horizontal asymptote, but it has a vertical asymptote at x equals 0. So if I ask for this function, if we are asked limit of natural log x as x approaches 0 from the right, what will you say?
Negative infinity?
Awesome. Thank you very much. Okay, another very important function is f of x equals arc tangent x. I think that this is a better notation than this. because I've seen students who say, oh, this is very simple. It's 1 over tangent x, which is cotangent. No. No. So that's why I prefer this. And also when I type, it's easier for me to type this instead of this. So they mean the same thing. They mean the inverse function of tangent. So now let's graph this because it's a very important function and we'll see it over and over in Calc 1 and Calc 2. So arctangent, or the inverse of tangent, has 2 horizontal asymptotes. One which is y equals pi over 2, and the other one which is negative pi over 2. This one actually is at infinity, and this one actually is at negative infinity, but I cannot graph a horizontal line and just say, show this piece. Say, here's a horizontal line, or just show this piece. No, I have to show the whole line. And now here comes the graph. So this is the graph of f of x, arc tangent x, or tangent inverse, or arctangent, tangent inverse, arctangent. So please remember the graph of arctangent. And now here's the first question. Limit of arc tangent x as x approaches negative pi over 2. Of course, is negative infinity. That's what I meant. And I gave out my answer already. See? At negative infinity, what would you say? What is the answer?
Negative pi over 2.
Thank you very much. Thank you very much. What if I write now limit of arc tangent x as x approaches infinity? What will that be?
Pi over 2.
Silly me. Which means, again, y equals negative pi over 2 horizontal asymptote at negative infinity only. And here, y equals pi over 2 means horizontal asymptote at infinity only. Okay, now one discussion, one theorem that I would like to discuss, and then we can look at problems. So the limit of 1 divided by x to the nth power as x approaches infinity, only if n is positive. What do you think this will equal to? We had a simple example when n was 1. What do you think this will equal to? Always and forever.
0.
Yes. Because I'm dividing, I shouldn't write this, but for clarification, I'm dividing 1 pi by infinitely many people. How much will you get? So if I divide $1 by infinite, or a pi by infinite, no one will get anything. Right? So 1 divided by infinity approaches 0. And this is what this is, 1 divided by infinity. Now, if n is negative, is a different situation. So just keep this in mind. And now, slowly but surely, let's see how we apply all this. I'm going to try not to touch that. Stay away from it. I have to plug in my stuff here, but after class, I don't want to mess it up now. Okay, so we want to look at different situations with, let's look at some graphs first, quickly. And let me close this up so I don't get logged out. Okay, so I'm back. Okay. I did write a note and I said, listen, in the middle of the class, I'm logged out. How is it possible? So they said, well, close that. So I closed it. Oh, we'll see what happens. Okay. So first of all, I would like to look at, can anyone give us the limit as x approaches negative infinity? What does this function approach as x approaches negative infinity? as x approaches negative infinity, we get
3.
yes, we get 3. We get 2. 0, 1, 2. Yes, perfect. As x approaches negative infinity, the function values get closer and closer, closer and closer, closer and closer to 2. Awesome. What about the other end? As x approaches infinity?
-2.
-2. So y equals 2 is a horizontal asymptote at negative infinity, and y equals -2 is a horizontal asymptote at positive infinity. Perfect. Awesome. I would like us to look at an example of this kind. 5, 6, 7, 8, 9, 10. So let's choose one, a very important situation. We learn a lot from this example. We learn a lot from this example. Okay, if you don't want to choose, I will choose a 7.
10.
Which one?
10.
10. We want to choose 10. So we had a similar example last week in a different situation. So we have limit as x approaches negative infinity of f of x equals -1. Limit as x approaches 0 from the left of f of x is infinity. Limit as x approaches 0 from the right of f of x is negative infinity. Limit of f of x as x approaches 3 from the left is 1. F of 3 is 4. Limit of f of x as x approaches 3 from the right is also 4. And finally, the last one, limit as x approaches infinity of f of x is 1. Good. Awesome. Again, as I mentioned last time, this is gibberish. I have no idea what this means. It means nothing to me. But if I organize it correctly, it will speak to me. Right now it says nothing. I take it step by step, and I will start with this. F of 3 is 4. So negative infinity is 0, 3, 4, infinity. So this is done. Then I see at negative infinity, the function approaches -1. I make myself a note, y equals -1, horizontal asymptote. Done. 0. 0 from the left. Oh, okay. 0 from the left, infinity. Okay, done. 0 from the right. Okay. Negative infinity. Done. I leave it open because they are not giving me a function value at 0. At 3. 3 from the left is 1. Okay. +1. Done. From the right of 3 is 4. Done. And finally, the limit as x approaches 1 from either side is infinity. So 1 here, I'm going to rewrite it. I'm going to remake it because it's too crowded and I don't like it. So negative infinity, -1, y equals -1 horizontal asymptote. So I have 0, 1, 3, and infinity. So on the left and right, infinity, negative infinity. Here I have on the left and right, infinity, infinity. And here I have 4, and then 1, and 4. So I'm going to erase this because I organized it better. Good, so clearly here x equals 0 is VA. Clearly here x equals 1 is a VA. And here is some situation. So when I start graphing, when I graph functions with asymptotes, what do I have to graph first? Every time I graph functions with asymptotes, what is the first thing I need to graph?
The domain.
The domain is the function itself, the values.
0. If it's an option, no.
Okay, so let me say it again. When we graph functions with asymptotes, what do we have to graph first?
Probably the asymptote.
Yay!
I also have a question. The way that you marked that x equals 1, I didn't read that equation the same way, or the function the same way. I thought that was like a y equals 1 and x equals infinity.
Oh, I'm sorry. Yes, yes, yes. Thank you. Thank you. Thank you. Absolutely. When x approaches infinity is 1. Thank you. Thank you. Thank you. Thank you. My mistake. Thank you. Thank you. Absolutely. Thank you for not allowing me to graph that. Thank you. Absolutely. Y equals 1 is a horizontal asymptote. So the limit of f of x is 1 when x approaches infinity. Thank you. My apologies. Absolutely, yes. So rushing is never good. Never good. Okay. So when we graph functions with asymptotes, we must graph the asymptotes first. That is always the case. So I see several asymptotes, -1, but I cannot just graph this piece. I have to graph y equals -1. So this is done. I have to graph x equals 0, but this is clear. This is already here. It's the y-axis. And then here I have y equals 1, but I cannot graph this. I have to graph the entire line that represents y equals 1. And now we are ready to start. And the first point that I want to start with is 3. 1, 2, 3. And this is 1, 2, 3, 4. And 3, 4 is a full point. Then on the left-hand side, I have 3, 1. So 3, 1 is this point, and it has to be an open point. This is an open point. This is a full point. But now because these two values are the same, this will start here. And then it approaches the horizontal asymptote. Very easy, nice and easy. No problem there. So on this side, the vertical asymptote x equals 0, and then it's coming from -infinity. And it approaches, in my example, you can find something else. You can graph something else. This is not a unique correct solution. You can find infinitely many correct solutions here. And then on this side, it's going to infinity, so up here, but it's coming from -1. Fine. So this is my example. And you can invent many more. All the conditions are fulfilled. So the horizontal asymptote is -1 at the -infinity. Vertical asymptote positive on the left, negative on the right. The open point 3, 1. The full point 3, 4. And approaches, thank you, my mistake, and approaches 1 from above. Or you can say, oh, maybe I want to do this. Or maybe I want to do this. It doesn't matter. Any example that fulfills the given conditions, you can add on whatever else you would like.